Hey there, class. We're here today to learn a little bit about vectors and specifically how we're going to express the direction of a two-dimensional vector. In previous videos, we've talked a little bit about what a vector is, and I'll have a link to that for you here. But today, our purpose really is to understand the idea of how we're going to express these directions. So let's take a look and let's consider these 5 vectors that we have drawn here. Now, hopefully, it's pretty clear here to you, or at least what I'm trying to show, is that these all have about the same magnitude. In other words, they're all the same length. Okay, so we'll just say for our purposes, let's say the magnitude of each of one of these is 10 meters. Okay, so the magnitude equals 10 meters. Now, of course, what we also need to know is for a vector to be a vector, it has to have 2 things. One of those things being magnitude, which all of these vectors do, but the second thing that all vectors need is a direction. And so let's consider these vectors here. Certainly, you can see that this vector here, if we were to truly define it, it would be 10 meters at a direction of north, or a northerly direction. Here, for vector E, that's going to be 10 meters at an angle or at an easterly direction. Okay, now what about vectors B, C, and D? So my question to you is this. They're all kind of headed off in this general direction here, right? So that's northeast, isn't it? Do you think that simply saying northeast is good enough? And so to consider this, I want you to think about what it actually means to say northeast. Okay, and northeast is a very specific direction. Northeast is exactly halfway in between the north and the east. So only one of these vectors would actually kind of fit that bill. Hopefully you can understand here that that might be, and again, I'm doing my best here to draw this, but this would be this vector here where it's from, we can measure from the east up to the vector C. And if as long as this is 45 degrees, then we're going to have a northeast direction. Let me get rid of some things here, clean things up. Okay, so let's say for our purposes, that vector C was in fact 10 meters at northeast. All right, and so now we're left with this problem where we have this vector B here. Again, its magnitude is 10 meters. But the direction isn't exactly northeast, not exactly north either. It's somewhere in between. So how exactly are we going to handle this? So I'm going to scroll down here and we're going to take a look at some ideas. So in your math class, you may have remembered, let me draw that vector back out here. We have it, it was about here, that was the vector B. In your math class, you would have had your axes is the positive x-axis here, the positive y minus x, and the minus y. Probably in your math class, you also said that this was 0 degrees, and you would start at this spot and you'd start measuring, you'd rotate around this way, and you'd find some angle here, and then you'd define that as, you know, we're going to just say, I don't have a protractor here, we're going to say it's just 60 degrees or so. And that's how you'd do it in your math class. Well, I'm not your math teacher, so we're not going to exactly use that, although that is very valid for your math teacher. Let me kind of talk a little bit about in physics, when we talk about directions, we're generally going to speak in terms of north, east, south, and west. So let me remind us a couple things. If you were to look at a compass, your north would actually be listed as 0 degrees, east would actually be listed as 90 degrees, south would be listed as 180 degrees, and west would actually be listed as 270 degrees. This is what's known as bearing. Okay, if you talk about a vector B here, and you talk about its bearing is going to be in some direction relative to the north. And in this case, if you were talking about bearing, you're going to actually start at the north and you're going to measure over in the clockwise direction to that. So again, if this was, let's say, 60 degrees here, this is going to have to be the complement to that. In other words, 30 degrees. So one way we could talk about this vector b would be to say vector b is equal to 10 meters at a bearing, or just you could simply say bearing 30 degrees. That would be one way we could actually describe this. Another way we could describe this is sometimes I refer to it as north of east notation. And basically the way this works is you take a look at your vector, and in this case, this vector is 30 degrees. The 30 degrees is right here, okay? And that's going to the east. Notice over here is the east. Here's the north. It's going 30 degrees to the east of the north. So a second way to describe this, let me do it in a different color. This would be 10 meters at 30 degrees to the east of north. Okay, and again, I call this north of east notation. I don't know if it actually has a name or not. That's what I've always called it. But basically, and again, this is just it's not always going to be north and east. Let's actually do another one. Let's put another vector up here. Let's do a vector down here. And in this case, let's say the angle we measure in here was, I don't know, let's say it was 20 degrees. So this angle right here would actually be 20 degrees south of east. Notice the 20 degrees is measured in here, and it's going to the south from east. We're going from here down this direction. Okay, let's do a third one. Let's say we have a vector down this way. And let's say this angle right in here, I don't know, we'll just say it's 25 degrees. This angle right here would be, notice it's being measured relative to the south, so it's going to the west. So this would be 25 degrees west of south. All right, so this is another way we could actually notate angles in a two-dimensional vector. Now, another way I'd like to take a look at here is that sometimes we don't travel north, east, south, and west. Sometimes in physics, we actually travel in an upwards and a downwards direction, in a physical upwards and a downwards direction. And so I want you to think about this in kind of more of a three-dimensional way, where this would be our positive x-axis. We could call this the positive y-axis, and we could call this a positive z-axis. Where our positive z is an up and a minus z would be the downwards direction. So if this were, you can kind of think of this positive y going into our board. That could be the actual north, this could be the east, this could be the south, and this could be the west over here. And sometimes when we do something, specifically if we're, let's say, taking a ball and we're throwing it, we're not throwing a ball necessarily northernly. Well, we could be. But let's say in this case, I throw it, I'm standing here in the west and I throw it to the east. This ball would actually travel kind of in a direction kind of like this, and it would land over here in a more easternly direction than where it started. So notice here it's going to be traveling kind of in an upwards direction and an easterly direction. So when we talk about how it's moving initially, we might talk about its initial velocity, and its velocity would be measured kind of like this. And it will be measured in this angle right here, where the direction here is kind of like the horizon. Okay, this is the horizon. And this angle right here would be the angle that we measured. And I don't know, I'm just going to throw a number out here. That looks like about 35 degrees. So I might describe this vector as, it's a velocity. I might describe this vector as something like 10 meters per second at 35 degrees above the horizon. Notice I'm going to just abbreviate it here with above the horizon. So there's above the horizon. Okay, so above the horizon. Or you can say horizontal, and that's fine. And what if it was BTH? What do you think BTH is going to stand for? All right, so hopefully maybe you figured this out, but if I can throw something above the horizon, I could also throw, if I was on top of a building or something, or standing, above the ground, I could throw it down in a direction kind of like this. And that would be measured here in this angle. So this would be below the horizon. Okay, so again, a different way we could kind of notate a direction for vectors is this. So let's go back to the top where we started this lesson. Here we are. We're back here, and where we left off, we were talking about this vector b, and we were talking about its direction. Now, of course, I'm just making these numbers up. I don't actually have a protractor here, but if we were to measure this angle, let's say it was 30 degrees. And one way we could talk about that is we could say it's 10 meters bearing 30 degrees, because 30 degrees is measured from the north. Or another way we could say this is, again, this angle in here is 30 degrees. We could say 30 degrees, and it's being measured from the north. So it would be going to the east of north. So 30 degrees east of north. Likewise, down here, let's say I was to have a protractor and I measured this right in here. One way we could talk about this is saying 10 meters at 20 degrees. It's supposed to be a 20 degrees, and we're going north of east. And if we were doing it in the bearing, well, bearing would be measured from, let me get a different color, it would be measured from the north all the way over here. And so that would be the complement to the 20. And in that case, that would be, if you were bearing, I guess that would be 70 degrees. Okay? So as we work through vectors this year and we deal with two-dimensional vectors, there's going to be a variety of ways that we can use, and this is hopefully making a little bit of sense.